You're not that deep into the finance major yet? Okay. All right, but today's stuff is very intro-ish. But intro-ish, but something that everybody should graduate here with. Basic time value of money. We are going to get into more details than I do in just about any other class. So we'll get into a little bit more detail because we've been talking about bonds. What are bonds again? Bonds. IOUs. From who? Banks, companies, governments. I mean, it's just an instrument. I mean, what makes it a bond is that it's a marketable security, so you can buy and sell them on Wall Street. So that we talked about some of that stuff in the previous chapters. And so today we're going to look at valuing flows. And we'll tie it specifically to the bond market, but I want to keep it real generic at first. So what I'm going to present now is something that's not presented this way in the text. So, thinking about rates of return and present value, future value. All right, so I like to categorize investments of any sort, whether you're buying a classic car, a piece of real estate, or a bond, or a stock, or whatever it is, into three sections, or three phases. So 3 phases of an investment. And for me, this has really helped me keep things straight because you can apply it to whatever it is. Again, classic car, real estate, stocks, bonds, whatever. So in the first phase, and I think in some other classes you might have seen me do this. You have what I call the first phase is the initial investment. The initial investment, II. This is basically an outflow of funds. Outflow of funds initially. When? Today. So this is today. I'm buying something now. And then at the end of the day, at some point in the future, you sell it or you get rid of it. So you have what we call a terminal cash flow. So this is the final inflow of funds. And then in between, you have operating flows. These are operating flows. Now, with a bond or something, there's not too many operations going, but it's whatever's going on in between. So these are inflows or outflows needed to maintain investment. Whatever it is. A classic car might need some gas for the gas tank. So you might have some gas, you might have some insurance that you're paying $50 a month on. So I bought a classic car, I paid $20,000 for that car. I'm gonna hold it for the next 1, 2, 3, 4, 5 years. Over the course of those 5 years, I'm gonna have, maybe I'm trying to build its reputation by winning some blue ribbons at we got the big car show coming up to Ottawa here next weekend, 16th, 17th. So maybe I have some entries for the car show or something, right? So whatever those ins and outs are over time, and then I think 5 years from now, the classic car market's hot. I should be able to get 30 grand for that 5 years from now. So I spend 20 grand, I'm out a negative 20 grand today. I hope to have an inflow of 30 grand, and then I spent some money. So the picture of that might be I'm out 20 grand, and then I'm out $100, I'm out $500, I'm out $200, I'm out $600, and then finally I gain $30,000. You know, what is my rate of return on that classic car given that information? That's all you need. So once you have these three phases, now we can talk about buying $20 worth of bonds and the inflows of or outflows of coupon payments over time, and then the potential sale of that bond in the future, or the redemption of it if you hold it all the way to its maturity, the final payment of principal or the face value back. If you got a piece of real estate, you're buying a rental property, that was the down payment on a $100,000 house. You collected rents, you had expenses, and at the end you sold it for something. Right? So all of that stuff can be factored into those three phases. Questions or comments on that? All right, so time value of money. It just so happens. Suppose you got $1,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So suppose you got $1,000. Don't bug me later. I usually don't have $1,000, but how many of you had me for personal finance? Okay, I did the $1,000 thing today, so that's why I have $1,000 plugged into my wallet. So all of a sudden it dawned on me, like I was going to use an example. Yeah, it is almost like that's what I should have done. I should have said, and you make $1,000. It's not like that. I probably did a little abracadabra. So example, suppose 10%. Suppose you've got an interest rate, a nominal interest rate of 10%, and you invest $1,000 for 1 year with annual compounding. How much you got at the end of the year? 10%, you invest $1,000, 1 year, annual compounding. What's your total cash flow at the end of the year? 1,100, right? So I started with 1,000, I gave up 1,000. I only had one time period, so I'm only going 1 year. It was annual compounding, so there was no compound interest going on. So at the end of the year, I got my 10% interest of 100 plus my principal back of 1,000. So in this equation, we can calculate the amount of the future value by taking my 1,000 plus my 1,000 times the 10% equals my $100. Now, if I do it again for 2 years, what do I have at the end of 2 years? Getting a little more fancy with the math, but same annual compounding. I let it ride. Logan? 1210. Good. How'd you get that? With the 1,100, right? So now I've got 1,100 plus 1,100 times the 10% equals $1,210. So 10% of 1,100 is 110. I'm adding it back onto the 1,100 I had. I've got $1,210. All right, so what if we simplify things a little bit? How can we do a little algebra, a little tiny bit of algebra, and simplify this expression a bit? Just a simplification, you're not solving anything, but rearranging the terms, it slightly simplifies it. x plus or 1.1? Yeah, 1.1. So we got 1,000 times 1.1. So just instead of doing the 1.1 though, let me skip that step and say 1,000 times 1 plus the 10% equals the 1,100. All right, and this one we can do the same thing, right? 1,100 times 1 plus 10% equals 1,210. And now, if I was letting it ride like I said it was, this sucker is right here. Right? So let's do that, but let's put this sucker in there instead. So 1,000 times 1 plus 10% is this, now equal to this, times 1 plus 10% equals $1,210. How can I simplify this expression? Squared, right? So 1,000 times 1 plus 10% squared equals $1,210. And so are we home free with the present value, future value formula? This is it. This is the foundation of finance right here. Just through these 3 steps, we've got, let me go with green because we're in the money. The present value, $1,000, times 1 plus the interest rate, little I, raised to the n power, the number of times we're compounding, equals the future value, 1,210. All of this from running our $1,000. Sorry, I had to use the prop. I had to running our $1,000 through the investment machine, right? The 1,000 turns into $1,210 in the future. All right, questions on that? That you've hopefully seen multiple times in other classes. Maybe you didn't see it presented that way. Some of you have had me maybe saw it this way. All right, so this one, like, if you ask this question to the general public, they can calculate what it is, right? This step, they start to get a little bit, maybe the 1,210, but they can understand it. But once we get to this abstract level, people start to lose it. They don't quite get it. But it is all there from this basic foundation. And then, more importantly, do a little algebra to solve for the present value, because that's the one that's up the most. The present value today of a future payment is the future value divided by 1 plus the interest rate raised to the n power. All we did is we undid this one. Here I'm starting with my 1,000 and I'm going forward, which our brain works that way. We kind of get that. But what seems to be more difficult is to bring the $1,210 backwards. But the math is exactly the same. If this problem said, if you were planning to get $1,210 1 year from now, and you value money at 10%, what's it worth to you? I'll give you $1,000. 1,210 divided by 1.1 raised to the 2 power gives you $1,000. It's just going backward and forward with the same formula all the time. All right, questions or comments there? You need to have this memorized. So a couple things here. This is N is the number of time periods. Number of time periods with the compounding. This is the interest rate, nominal interest rate, I might add. What was the difference between nominal and real? We touched on that last time. We're going to bring it up again today. Yeah, one's been adjusted for inflation. Real interest has been adjusted for inflation. Nominal is just the rate that the bank gave you off the shelf. So if your banker tells you they're going to pay you 10% on your investment, then that's the right rate to put in here. So this is the nominal interest rate for those time periods, for specified time period. So this is where we get a little bit more complex than I ever do in any of my other classes. So let me change this on you. Interest rate is 10%, but we're going to have 12 months of compounding interest. What do you got at the end? So interest is compounded monthly. So what if interest is compounded monthly instead of annually for this particular problem? So I'm kind of adding on to an extension of example 2, example number 1. What's that? I don't want you to pull out your calculators at this point. I want you to tell me how to do it. What do we need to modify the formula? We got a 12. That's good. We're going to compound 12 times. Is that the only adjustment we need to make? If we were to just do the 12, what would we be effectively doing? If I put the 1210 or whatever, if I took my $1,000 and I put a 12 in it, what would be effective to get at the end? How many? 12 years. We just did it 12 years. So in order to make apples and apples, what do I need? What other adjustment needs to be made if this is monthly? What about the I?
The nominal interest rate has to be over the same amount.
Over the same amount of time periods. In other words, it needs to be a monthly interest rate, right? So whenever we do interest rates, we typically express them as annual rates. And so in order to solve this problem correctly, the 10% has to be divided by 12 to make it a monthly rate. So the way to solve this problem now is to take the present value is equal to the future value. In fact, this might be kind of fun. Let's see what $1,210 going in reverse does. 1 plus the interest rate of 10% divided by 12 raised to the 12th power. Now, before you do that, should it be greater than 1,000 or less than 1,000? Less, okay? So now you can pull out your calculators if you guys got it. I'll allow you to pull out your phone as long as you keep it silent on other things if you want. I don't have this worked out ahead of time, so I'm totally relying on you. So a couple of you, if you don't have a calculator, no big deal. We'll get enough people backing each other up here. As soon as you get an answer, shout it out. We'll just compare notes with other people. And it ends up being kind of a mess to plug into your calculator. I would probably do the 0.1 divided by 12 to get that number, add 1 to it, raised to the 12th power. So you got to know how to do the power thing on your calculator. Go ahead, don't be bashful, give me some numbers. It doesn't matter if you're wrong. What do you got? 1,095.
That's what I got.
That's what you got. So check, check. That's another one. No, somebody else got 1,095. Anybody else? 1,095? 1,095? No, for this one, we'll just leave it 1,095. Yes? Okay, now I thought I heard some people say it was going to be less than 1,000. What happened here? So does the compounding work to your benefit or your detriment? Detriment? Maybe? Benefit? Yes? Turns out you're both right. Why? It depends on, not so much if it's going down, it depends on what? The person who's doing it. Are you on the receiving end or the giving end? Right? This is a transaction between a lender and a borrower. What works, it's kind of a zero-sum game in this sense. What works for one comes out of the pocket of the other. So, how does the credit card companies typically compound? How do the credit card companies typically compound? Monthly or annually? Monthly. Same thing with house loans, car loans, everything's monthly because we're thinking about borrowing. Let's see what happens here. Take your $1,000 and project it into the future. 1,000. Take your $1,000 and do the same calculation of 1,000 times 1 plus the 10%, 0.1 over 12 raised to the 12th power. What does that turn into? Hypothetically, if you were to get compound interest by investing it, what'd you get? Shout it out.
905.
905. Anybody else? I don't know if that's the right answer. I haven't worked this out ahead of time. Do I have a second? Nobody. What did you get? Don't be bashful. What'd you get? Kaylee? Huh? 1104. 1104 gets a double check. 1104 gets a third check. 1104 gets a fourth check. All right, I'd say we're good at 4. Sorry, 905. You're apparently wrong.
Apparently.
Shoot.
Now, how long did we go? 2 years or 1 year? What is it for 2 years? What is it for 2 years? 1,000 times the 1 plus 10% over 12 divide or raised to the 24th power for 2 years of compounding. 1220. That sounds right. Did somebody else get 1220? Okay, 1220. Now we see why the credit card companies are doing monthly compounding, right? This 1220 we can compare to the 1210, right? So consumer, they're like, oh, who cares? They do annual compounding, monthly compounding. It's only $10. But if you've got 100,000 customers, it's a lot of dollars, right? $100,000 times $10 for each customer is a bunch of money. So that's how the monthly compounding, annual compounding business kind of came in. Some of it is short-term in nature, I think, is part of why it's monthly compounding also. So if you ride a balance on a credit card or something for 6 months or whatever, it's just monthly compounding. Otherwise, you'd kind of be reversing. You'd have to do some weird math to estimate the pro rata amount of interest as well. All right, any questions so far? All right, so get comfortable with that expression. That is the number one in finance. All right. This looks kind of like a fun one. On your notes, without pulling out your calculator, on your notes, using 10% interest and annual compounding, show me how you would calculate the present value of this stream. what I'm trying to do is say, is today's price for the classic car worth it? You know, I think 5 years from now it's going to be worth 30 grand. And here is what it's going to cost me to hold it. Using a formula only, I don't want you to pull out your calculators for this one. Show me how you calculate that. I'm going to walk around the room, and if you need a little help, I'll give you a nudge. But I want you to tell me what is the present value of this, and assume this is 1 year, 2 years, 3 years, 4 years, 5 years, okay? What is the present value? Here's your formula, of course. What is the present value of this stream of payments, that stream of flows?
Yeah. And this one. Yeah. Right, so how does it? Well, we have to take this back now and this back 2 years, this back 3 years. But the interest rate.
Okay, you got your nudging marker. Nudge. All right, I'll work my way back up there. You got this? Okay.
And we're assuming the family.
Okay, this is a good start. That is the right formula for that flow. But now you've got those ones in the middle. And for make sure you think about them each in their own way, because they're each coming at a different time frame. You've got to train their. What do you got? Nothing yet? All right. So think about each one individually. You got it. You do have to treat each one. So this is a good start. This is absolutely correct for the last cash flow. But you've got the negative 600, the 200, the 500, and 100. You got to deal with one of those. And treat each one individually. Okay, where did you start? Did you set them all up? So you don't want to do that because each one in each time frame. So like, it wouldn't be fair that the $600 that you got in year 4 is actually more valuable than the $600 you would have gotten in year 5. Right? So each one is treated individually. Okay, yep, I'm liking that. Now you can pull your calculator out and solve for that.
Are we getting 20,000?
Not yet, no, just we're just doing the flow. All right, you guys needed a nudge? Okay. Okay, so no, actually, I mean, this is right for just this one. But each one of these has to be treated differently. No, you can't just subtract it. You can subtract it at the end, but not at the beginning. So you got to calculate that, and then you do each one individually. You have to do one of these. You have to do one of these for each one of these individually. Okay? No. What do you? Which first one are you doing? We're back to this one. Yeah, on the 10%. Yep. Yeah. So it's just annual compounding. What was this thinking?
Have you subtracted 100?
Oh, from here? Yeah, no. So you're looking at, you did it right. Why don't you explain what you did? That was right, what you did here. Okay, looks like a lot of you got the right thing going on. Anybody else need a nudge? I want to nudge you now. Okay. Yes, but now this 100 though came in time period 1. And then this 200 came in later. That was actually 3. Yes. So treat each one of those individually, and then you're going to end up adding up. Okay? I'm going to go through it too. I just wanted you guys to get, it's important for you to start with the inertia in your brain, and then I'll try to continue. Where'd this come from? No, we don't have, there's 20,000 words ignoring. So you did this one right. But that first year one, you got $100 negative divided by 1.1 raised to the 1. That's your present value. That. Then you're actually going to be adding or subtracting, depending on which way you look at it. Logan, did you come up with a number? Okay. Okay. Yes. Yep. Oh, yeah, you got it. That's right. All right. We'll go all through it together. Again, I basically wanted you each to get the general game plan in your head. If I told you you had it right, which I think there was only 2 of you that I did, go ahead and calculate the answers. I think Logan already calculated his, but Zach and Mitchell or Mitch? Why don't you guys calculate your answer on that while I'm laying it out. All right, so the present value of a stream of income is equal to whatever that is in whatever time period it is. So you're going to follow this formula, but and I think most of you started to get this, the first cash flow discounted by 1 raised to the 1 time period because it's in 1 year out, plus the second flow calculated on its own, negative 500 over 1.1 raised to the 2 power, plus the third flow, which is also happens to be negative 200 divided by 1.1 raised to the 3rd power, plus negative 600, 1.1 raised to the 4 power, plus 30 grand positive raised to the 1.1 raised to the 5th power. Oh, Mitch and Zach, did you guys get a number yet?
Not yet.
Did you get one? What'd you get?
But I got 17,203.
That sounds similar to what Logan got. Logan, what was yours?
17,564.
Okay, so we're in the 17,000 range. Let's take each component separately. I don't know, did you guys do it that way? Because I'd like to just lay this out. What's this number? Negative 90.91. 413.22.
Negative 150.26.
Okay.
Negative 409.81.
409.81 plus
18,207.64.
0.64. Logan, you were close on these, or there might have been a little rounding error or something. But
I have 18,006. 6 and 2 are backwards.
Yeah,
But I
627.
okay. All right, and you guys were real close on your answer. And so if you add up all these numbers, now notice I kind of did this in a Dorcas non-mathematical way here by I added a negative. Those are really all minuses, but I wanted to be preserving the concept of what's going on here. 17,000 what?
564.44.
Should we buy the car? No. All right? So today, somebody's asking 20,000 for the car, and I value this future sum of money at $17,564 today. So it would be kind of stupid to give up 20,000 to get something that you value at 17,564. Right? Yeah? All right, so concept this is related to is the net present value, which you might have saw in some other classes too. The net present value is equal to the initial investment. I'm sorry, the present value, screw that up. The present value of the future income stream whenever we see the word net, what has usually happened? There's been a subtraction of something from what follows, right? So it's net present value. We're going to subtract off the initial investment. And in this case, we get 17,564, 44 minus 20,000 gives you, somebody want to help me out there? Approximately 2,500. What do we got? $2,436, $2,435.56. 17,000. Oops, that's $2,435.56 negative, right? The difference between the two. So when the net present value is negative, if it has a negative value, what does that tell you? Don't do it, right? And that's the whole thing with the net present value calculation. So if NPV is less than 0, don't do it. If net present value is greater than 0, do it. If it's equal to 0, you're indifferent, but be careful. But usually you'll probably end up doing it because you probably want to do it anyway. So if we don't do it, what should we do? Bargain to go cheaper, so that would be one thing. You'd still like to pick up this car if you could negotiate it down to at least what price? 17,564, right? So now we use the finance to say, hey, man, you got to come down. How about 17,000? Oh, I can't go that far. Okay, bye-bye. Right? So you've used the finance to kind of calculate what you thought was a reasonable offer today, given the future. Okay, so that's one thing. If you don't do it, you can negotiate. What else could you do? Yeah, let's say you did your homework. You're thinking whether this went up. What do you mean, what it's really going to be worth? That's true. That would go up. But let's assume that you did all your homework and this is the best, most conservative number that you think you could. So this is one of the things, since you brought that up, I've tricked myself. Don't do this. But when you make these spreadsheets, you can find the answer you want. That's not being very scientific about it, though, is it? Right? So I want to buy this car. I prove it to my wife that this is a good investment because I'm using my retirement money. Right? And so I do the calculation. Oh, crap. Well, I know it'll be worth $35,000. Now, how do the numbers come out, right? But that's not being very scientific about it, right? And so when you do these spreadsheets, what I hope you come away from with your undergraduate education in economics, finance, and accounting is that you can pick apart some of these spreadsheets that you are going to see at work in your boardroom. You need to drill down what are the variables that are actually driving that outcome. And you're picking on the right ones. Tweak this variable. So a good question in the boardroom is, well, how did you come up with 35,000? How did you come up with 30,000? Because we know that that number is driving this answer to not buy it, right? And so, oh, well, we did our research. We studied 3 different sources and historical records of classic cars and blah, 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 blah. Okay, they did their homework. Or did they do this? And a lot of people do that. Throw a dart at a dartboard and kind of eyeball what that number needs to be. And if your results are pretty sensitive to that, and this is another thing that you guys can do as a young and up-and-comer at your company, is to do a little sensitivity analysis. ask them for their spreadsheet, change this to 32 and then down to 28 and see how much the outcome varies. Because we can start to think about, well, what is the uncertainty with my prediction of what the future number is going to be? That's going to be important. All right, so what else should you do if you don't do the classic car because you've done this and you feel like 30 is a good number, that it wasn't just a dart at a dartboard, you did your homework? What should you do? Where should you put your money? Elsewhere. Where's that? How much are you going to get elsewhere? How much are you going to get elsewhere? 10%. Why, Tag? That's right. Damn it, that was your number to begin with. That's your money, right? That's the opportunity cost of your money. That's exactly why you did this in the first place. You weren't just given 10% by the professor. You actually thought about your life and what else you could be doing with your money. You did your research, you checked your people, you checked your other investments, and you feel like if you didn't place your money with the classic car, you could be putting it into a growth stock mutual fund and reasonably expect X. Whatever that X is, that is the opportunity cost of your money. It's what you could be doing if you didn't do what you're doing. Therefore, if you get an answer of no, you go do it. You've already identified your next best alternative. You know what I mean? It's there. That's how the whole setup, that's how it works in the first place, is thinking about what our opportunity cost is. So, if no, do your opportunity costs. Don't do it. If NPV, I'll just add on to this, you can add it in your notes however you want. If NPV is less than 0, then do your other opportunity. Do your other opportunity with 10% return. Now, is the return on the car less than 0? Is the return on the car less than 0? 0%. Is it a negative return on the car in terms of rate of return? Is it a negative return on the, here, now kind of look back to this picture. Is it a negative return on your money? It's just not 10%, that's right. It's still possibly positive, and actually it is, I think, in this case, but it's not 10%. All right, so how do we solve for that? Well, instead of putting your little 1.1 in here, you can put the I back in here. And instead of solving for the number, you put 20,000 here. One equation, one unknown. Can we solve for I? Yes. What would be your first step in algebraically solving for I here? Filter out the I? How does that work? Where's my math people, my higher end math people? Simplify the exponents and let's see, what the heck is going on? Can we filter out the 1 plus I? If your brain is hurting, I'm glad, because it is impossible to solve for I. You can't do it. You can't solve this equation for I. It's impossible. So you have to go through an iterative process of plug and chug. So try a 9%. Try a 7%. Try a this. Or better yet, get out your business calculator and use the internal rate of return function. the calculator, the computer, will go through that same iterative process that you would have to go to hone in on it. That's the only way you can solve it. So in Excel or on a computer, you can't use a supercomputer to even solve for I. It's impossible. You can't solve for I. So it's literally a plug and chug method of narrowing it down. A little higher, a little lower, and then you narrow in, and then the computer cranks out. The older TIs used to like take a little bit of time. You could almost see them smoking, like they were doing a million calculations of plug and chug, and then presto, out would pop the internal rate of return of whatever interest rate it was. So using the internal rate of return function, you can solve for I. And as Chisholm said, that interest rate here is going to be less than 10%. So this interest rate is going to be less than 10%. How do I know that? Because we got this result. It has to be less. So that's how these two concepts go together. Internal rate of return and net present value are kind of kissing cousins of each other. The formula is actually the same, but with the net present value, we know what the interest, or we assumed an interest rate and we solved it. With the internal rate of return, we solve for the interest rate. Okay, questions on that? All right, we'll apply that to the bond market next time. See you on Friday.